ready to get started? We're a few minutes late because the keynotes ran over. So we'll try to get this done. It's a big topic, so I'll try to get it done as much as I can in the time we have. I apologize. I had a really bad cold a week ago, and I'm still kind of recovering. So hopefully I'm able to talk loud enough for everybody to hear me the whole time. So can everybody hear me fine? Yeah. Let me know if I'm fading off. I'll try to do a little better. So I've been an IT DBA developer. I've kind of done everything. Blah blah blah. You probably don't care. So let's talk about what slows down your web page, because that's what we're here to talk about, right? So there's a few things. You probably all optimize for content load time. You're making sure your CSS is minified, putting stuff on CDNs, stuff like that. Making sure your images are the right size. Thank you. There's also, sometimes you just have poorly optimized code that's slowing down your website. In my experience, stuff that's really slowed down a website drastically, I've experienced that particular one maybe 2 or 3 times. So it's not something that really, usually code slowdowns, yeah, 2 of them involved regular expressions kind of. The other one was instantiating thousands of objects and doing weird stuff before PHP really did objects well. So those, your code can slow you down, and you can have scalability issues because of your code, but those usually aren't the things that are causing the big, huge problems that you're dealing with that need to be fixed right away. It's usually, when you're getting those problems, it's usually the database. It's your queries to the database. So I assume everybody here is a web developer. How many of you have DBAs at your company? Okay, fair number. So a lot of companies don't have DBAs, though. Most of you are working for companies. You've got your development team, and you're kind of responsible for making sure the database works right? So you're kind of stuck with this, even though you weren't trained to be a DBA. You're a web developer, and with that job these days, often comes the role of making sure the database is happy. The IT guys will make sure the database is running, and they'll do some, deal with hardware issues and things like that. Maybe replication, but you guys are going to be the ones making sure that the queries running on your website are not bogging down the database. All right. The slides are on your chest. Okay. Sorry. Got some kind of weird thing going on with my slides. It's just showing up and disappearing. This isn't good. Worked last night. All right.
Is it Google Slides?
No, it's PowerPoint. This is what we're going to do. We'll just do it like that. That's good. Okay. So the assumptions for this session are that you're at least a average developer. You know what a SQL database is. You use a SQL database. We assume you know what joins are and how to use them. Yes?
Oh, sorry, it's just a signal into my
okay. I had a question. Do you know what an index is? When you might want to, general idea of why you would want to use an index. So those are our basic assumptions. The examples and output I'll be showing come from MySQL, but these principles apply pretty much to any database. It doesn't matter what database you're using. So the first thing, when I've talked to web developers, when a query is running slowly, the first thing you do is add another index, right?
No, absolutely not.
Well, everybody knows that indexes speed up your queries, right? So your query's running slow, you add another index, right? And that's often true. So in this case, one thing MySQL does a really good job with the explain keyword. You can run your query with explain in front of it, and it'll tell you what it's doing. In this case, it tells us, the first table it's looking at is the payment table. Possible keys, null. That's a bad thing. It's saying, well, there aren't any indexes that deal with this payment date. And so we're just going to look at the whole table. In this case, there's only 16,000 rows. You might not even notice that it's doing the full table scan. But it's definitely not ideal to be doing these kinds of queries without an index. Okay, so we add an index, and you see this changes. Before it said type all, and now it's type range. It's not looking at the whole table, it's just looking at a range in the table. It's using the payment date index, and you see the rows has gone down. It knows how many rows, based on the index, it knows how many rows it's going to have to look at. And that's important because it's not so much how many rows are returned that matter when you're optimizing your database, it's how many rows it has to look at before it can figure out what to return. Because looking at a row means accessing the disk, and accessing the disk is slow. So you want to avoid looking at the disk. And so getting this number as low as possible. Now if you're returning all those rows, that's great. You're going to have to return all those anyway. You have to look at them. But if you're looking at a lot more rows than you're returning, then there may be some ways you can optimize your query a little bit. So when is the index used? The index is used, how many have done a multi-column index? Okay. So for those who haven't, you can do indexes over multiple columns. And so it'll, if you specify this, this, and this, then it'll be able to use that index across the whole, to narrow down, right down to what you need.
As long as you order them that way in your query.
Well, no, they don't have to be ordered that way in your query. They just have to all be present. As long as, and it's the leftmost prefix of the index. So if you have an index across 3 columns, and you specify the first and second columns, it can use the index. You don't need to specify all 3, it'll use the left. If you specify the second and third column, your index is useless. Think of it like, the younger ones probably never had white pages, but if you had the white pages, how do you look up a name? If you know someone's first name, how useful is that? The first name is the second part of that index. The index is by last name and then first name. And so if all you know is their name, it's completely useless to you. You'd have to look through the entire phone book. That's the equivalent of a full table scan in a database. You have to look through the whole phone book to find who you're looking for. All you know is their first name. If you know their last name, but you're not sure of their first name, or even if you know their last name and the first few characters of their first name, you can narrow down really quickly, right? It doesn't even have to be, like if you're dealing with a string, it it doesn't have to be, you don't have to know the whole thing. Even knowing the leftmost part of that string will get you the ability to use that index because you're able to give that leftmost part. So if you think of it like white pages when you're looking at your indexes, that's how it works. Yes?
Hey, on a multi-column index, where in your example we're using latitude, longitude for the cities, is there
Yes.
ever be an example where we argue?
That's a terrible index. I'll tell you why in a second.
Okay, so my question though is, we've got some people who want to index, say, user, or first name, last name, and some unique ID. And then they'll turn around and say, well, that's when we are searching for a user by unique ID. But if I want to search by last name, I'm going to go ahead and create an additional index. On
Sometimes you need multiple indexes because of, you have to look at what's being specified in the query and will the leftmost prefix of the index cover it. Now you can, we'll talk a little more about when you can have too many indexes.
So can't you just index each of those columns, maybe you have 3 columns?
If you index them separately, it can only use, well, it's more efficient if you have one index covering all three.
Okay, so in
Depending
cases where
on,
you're going to be
depending
querying
on the
against all-
situation, it may be able to use more than one index. But in many cases, it can only use one, or it's less efficient if it has to use 2 because it's trying to do some, like it's looking up both and then doing a merge sort kind of thing on it and trying to figure out which ones are in both.
So it sounds like,
It's definitely less efficient than having something that just covers what you need.
right, so if you know that like you have 2 unique columns and you know that they're always going to be indexed together, it's always
Yeah.
best to multi-index that.
Generally, well, if they're each unique, then
Right, but you know that a query is
if they're
always
unique together, then yeah.
Right.
Yeah, put it across. Now, one thing, when you talk about the multiple columns, it's only if it's specified exactly. Now, I showed you before how it can use on that range, it used the index for the range. If you know, again, with the white pages, if I know my friend's first name and his last name begins with M, well, that narrows it down, but that really isn't, it's still a lot of pages to look at, right? It's definitely better than having to search the whole white pages. Just knowing that it starts with M isn't as helpful. I can't use that index very effectively. You have to, as you're going left to right, before you can move to the next one, you have to specify the last one exactly in order to be able to use the next part of the index. So I'm not in presenter mode anymore. Okay, so after a range, it's not going to be able to, like I explained, you wouldn't be able to use it. So this was an example I saw at a company that I was working for. When I got there, I saw this index and I was trying to think, when would that index ever be used? Because when you were looking, we were looking up points on a map. And so you were saying, okay, I'm showing this area, let me know all the points within that area. Well, you're giving a range for the latitude and a range for the longitude, right? And so in order to box in that map that you're displaying. So you're always going to have a range for the latitude. You're never specifying the exact latitude. If you knew the exact latitude, you'd probably know the ID for the point you were looking at. And so in this case, that index is not very helpful because it can't go from the first part to the second part. Yes?
Can't you just add a modulus of lat and long and say, I want, and set that aside as a separate column, and then index on that?
Yes.
So you're using
everything's-
typical
yeah.
grid sections?
Yeah, you'd want to, probably not modulus, but
We just like, the first
just
5.
grid, yeah, just basically grid it. That's effectively, like when you use Google Maps and all these, it loads tiles. That's basically, so you basically tile your map and you can get down to specifics. That's what we ended up doing in that case. So you can't have too many indexes. So you see here we have an index covering, just kind of show, in MySQL you can do show keys from the table name, and it'll tell you all the keys. And you'll see here, these two have the same key name and a different sequence and index. That means you have a multi-column index. And so it's over title and release year. Because sometimes you have two movies with the same title, but they're released in different years. They're not the same movie, right? But up here we have an index on title. What's the problem here? We have two indexes that give us the same thing, because if we know the title, we can use this second index. So we don't need that first index anymore. We don't need an index just on title because we can use that other index. Now why is that bad? Because whenever you write to the table, it has to update all the indexes. So the more indexes you have, the more your writes cost. So it's not just about it, it's useless for reading. It doesn't really matter. You can get by with one or the other. For reading, they'll speed it up just as much. But for writing, having that extra index will slow you down. It doesn't really hurt you for reading.
Sorry, what about, what if the scenario that the multi-column index had actually had the release year first? And then
If the release year was first, then it wouldn't be useful. If you just knew the title, then that index wouldn't be useful. So in that case, you need to have both. If that was, but you can look at your index, look at your queries that are happening and see, when you're doing multi-column indexes, think about what information are you most likely to have, and so that you can structure them in a way that they'll be used by the most number of queries. Sometimes you just have to do two indexes, and that's like if you needed the release year title to be separate, to be in that order, then having two indexes would be required, and you just have to live with that. So again, avoid full table scans. That's the worst case. It gets worse when you're dealing with joins. If it doesn't know how to join two things, if you don't have an index on how you're joining, you'll see when you're joining, the first row, or the first table, when you explain that, it might have more than one row. That's fine. You might be selecting more than one row. But after that, if rows is more than one, you've probably got a problem. Usually when you're joining, the tables you're joining against, you only want to have one row. You're joining on a specific thing. Sometimes that might be the case if you're grouping on that, but in general, it's best to get where you're using an index that, again, that you see the key is null here. That means it's not using an index for that join. It's having to look at the whole table and compare two tables. It's basically a Cartesian join that the database has to do in order to get you the information that you requested. And Cartesian joins are very bad. I saw once where someone had select star from table 1, comma table 2, comma table 3, comma table 4. No conditions on that. And he wanted to know where each table had 100,000 rows or something. And so you multiply those, it never came back. Whenever we ran it, the server would crash and you couldn't figure out what was going on. All right, don't put a query inside a loop. Let me figure out, okay. Let me make sure I know where the time is. My thing's not showing the time anymore. So don't put your query inside a loop. If you're inside a loop and doing queries, that means that you're hitting the database separately for each of those queries. So, basically, this is, most people know not to do this. I see stuff like, sometimes you see code on Stack Overflow or something, or something doesn't. But, yeah, inside a loop is a bad place to do a query. Try to figure out a way to do one query that gets all the information. Now you may think, I'm not stupid, I would never do something like that. However, your ORM may be stupid and may be doing something like that. If you don't, you have to know how your ORM works and what it's doing behind the scenes, so that when it's loading bulk data, it's doing it in a way that just does one query instead of moving through and loading everything it needs. So just be aware that most ORMs have a way for you to debug, to see what queries are actually happening on the database. So it's good to look at that sometimes and see, are we doing like 1,000 queries when this page loads? If so, we probably need to look at how we're structuring where our queries are happening, and can we make them more efficient? Yes.
I've heard the argument that it can be beneficial to do it this way, so that the large queries broken up into small queries, so that other queries can come in between versus one large query that locks the database for a longer period of time.
If you're using a MyISAM table,
Yeah,
that's true.
Yeah, don't use my ISO. Please, for the love of the children. Yeah, that'll save you a lot of problems. Yeah,
Can you explain what an SM table is?
yeah, we'll get to that. We've got that coming up. So there are other, so basically B-tree is your index. How many have done computer science and studied all the different kinds of indexes? You know, there's B-tree, there's R-tree, there's the whole green-red thing. Yeah, there's all sorts of weird indexes out there. B-tree is the one that's usually used in most database engines. There's also a hash index. A hash index is where you just hash the data and then index that. The benefit of that is you can put an index on something that's really big. Let's say you've got a URL. Again, remember, it's helpful for your indexes to be in memory as much as possible, right? Because you don't want to access the disk. If you get nothing else out of this, disk access is bad. You always want, as much as you can, to be just dealing with memory. But indexes, SSDs are about 1,000 times slower than memory. Hard drives are 1,000,000 times slower, so they're much better than hard drives. But they're still slower than memory. You still want to deal with memory as much as possible. So get as much as you can in memory. Having really long indexes makes it harder for your database server to keep that in memory. Maybe you really need to have a really long index, but maybe you don't. One example, I remember back in the day, this is back in like the early 2000s, it may have even been 2000. I was on the MySQL mailing list, and someone was complaining about the fact that MySQL didn't allow them to have an index longer than 1,024 characters. And, you know, people are like, why in the world would you want an index longer than 1,024 characters? And he said, well, I work for Yahoo. It's URLs. And sometimes URLs are really long. And I said, well, do you ever do range? So are you ever selecting URLs that are within a range? And he's like, no, why would anyone ever do that? Well, then just hash it. Now you have a small, you can put an MD5 hash on, you can get that down to, that's 128 bits, right? Hash it down to 128 bits, index that. You don't care about ranges, you're always looking for exact matches. So hash indexes are great for that, for exact matches. They're useless for ranges. If you want to find anything within a range, they're absolutely useless. So I believe Postgres, you can do hash indexes natively. MySQL has certain storage engines support hash indexes. Most of them don't. So it's kind of hit or miss. But you can always create your own hash index by just adding another column that's the hash of whatever you want to index, and then indexing that. You just have to deal with making sure that stays updated.
I've heard of people talking about a fractal tree index. Do you know what that is? I don't.
It's a different kind of index. There are, I believe if you use a Kona database, which is a MySQL variant, I think they ship with TokiDB now. as one of their storage engines, which does Fractal Indexes, which are really good for certain things and not good for other things, but there's some very good use cases for it, and it's definitely interesting technology. So, but it's a lot newer, it's a lot less robust than what people have been using. Full text indexes, if you're using MySQL, please don't use the full text indexes. They're really not that good. If you just need to have something occasionally, then sure, go ahead. But if people are searching your stuff with any degree of regularity, you really want to have something, Sphinx, Lucene, Solar, Elasticsearch, those are all indexes that are designed for full text, and they'll be a lot faster than the one built into the database. Spatial indexes, as long as you're on their recent version of MySQL, you don't have to worry about that. Postgres has had better spatial indexes for longer, but they let you have, like if you're doing mapping, you can index points and shapes and stuff like that, and see if the point is inside a shape using the index. They can be a lot better for that. So we talked about hash indexes, hash columns. I talked about grid index. Sometimes using an approximate index, just being able to narrow it down so that at least you're not looking at as many rows is the best you can do. Sometimes there's just no way to index it. You ever had, one of your executives or the sales manager or something, they want some report every day, right? And this report takes 45 seconds to run. And you set up a page for it, and they run it, and their browser gives up before the report actually is generated, right? Anyone had to do that? And in the meantime, I had to do this back in the days with MyISM, and so, we were locking out our customers while some guy was hitting F5 trying to get his report to load. We solved the problem. We said, do you really care about real-time data? It's like, no, we're generally looking at yesterday's data. Well, okay, at midnight, we'll run that query, put it somewhere, and when you want to look at the report, we've already got it generated. You don't have to do it every day, or do it every time he loads it. So look for things like that. You can also create a read-only copy of your database. Use Replication to create a server that's just used for running these kinds of reports. That way, when any kind of administrative report is happening, it's not affecting your users because it's happening somewhere else that's totally separate from what the users are experiencing. Eliminate redundant queries. This is pretty common sense. Don't do the same thing over and over again. Try to find ways to avoid making the same query more than once. So memcached, Redis, things like that are great for storing information, for caching it so that you don't have to go to your database, but keep it in memory, and it's very quick to access that data. If you're using an ORM, they often have built-in ways. You just have to enable them to do that. Yes. Did you say you had a question?
He said, we're really bad at that. I said, yeah, but our data code is not good at it.
Okay.
I actually had a question regarding
Yes.
your last statement on running the expensive stuff at midnight. What do you do if you've got a MySQL table and you've got international customers? What's your kind of general strategy at that point?
Replicate and run it on a server that the customers remember their stuff won't access. That's the best solution. That way, we would have our production stuff, and we'd replicate to our office, and we'd run that kind of stuff in our office, and that way, if something happened in production, we have a full copy of all the data, and we have a place that, we can run these kind of reports without impacting our customers. So there's different ways to do it. That's how we do it.
Sometimes you can also create a cron that only look at a fraction of the data at a time, and then switch that off somewhere and then look at the next fraction.
Are you going to mention materialized views? Is that?
Yeah, so if you're using, that's one thing you can do with the hash indexes. instead of maintaining the column, you can do a materialized column in MariaDB. I think MySQL 5.7 might.
Well, I had to do it, there's ways of implementing what Oracle calls materialized view.
Yeah, you can do a whole view that's a separate table.
Yeah, and that's what I do. I have reports that have to be accessed constantly throughout the night. It'll take 2 minutes to run. But by doing the materialized view, it just takes a few seconds.
Yeah.
That's another
Yeah,
strategy.
that's just a matter of how you're storing the information, that's it. You can store it, you can generate the whole page, you can generate a PDF, it doesn't matter what you do, just store the information somewhere
Yeah.
so that you don't have to do that all the time. So let's talk about MyIce real quick for those poor people here who are still using MyIce, and I'm sorry. So here's what's happening real quick. So you've got your read queue and your write queue. So you have some selects happening, everything's happy, right? Now we've got a select that happened that takes a couple minutes, right? So that's fine. You can have multiple selects going on at once. There's no problem with that. MySQL will let you have multiple selects all at the same time. Now you have an update happen that it's just updating one row. It's virtually instantaneous. However, your table's locked because that select's running and it's already started. It's going for a couple minutes. And so the write has to wait until that one finishes before it can go. Now all these selects that come later, they're quick. They can get out of the way quickly. But MySQL doesn't know how long they're going to take. It doesn't know. And what happens is that this update has blocked everything else from happening because it's higher priority. And so at that point, once the update comes in, until it's able to run, nothing else can happen. And so it's usually not big updates that slow you down with MyISM. It's the big selects that happen right before someone tries to do an update.
Does this table lock affect just the database or the entire database server?
Just a table.
Okay.
It's per table, so it's a table lock. It can.
But
In worst case, what happens is you end up, if you keep on, all these queries are waiting, and usually you have your database set up, it's got enough memory to handle 100 concurrent queries going on. All of a sudden they're piling up and you've got 3,000 queries waiting, and your server crashes because it runs out of memory, and bad stuff happens with the table update. It's not something you want to do. So with InnoDB and most other, InnoDB has been the default to MySQL for, I don't know, at least 8 years or something. It's been a long time. You really should be using InnoDB at least. It uses something called multi-version concurrency, which is what the rest of the world was using before, and really should have been used in MySQL before that. But basically what happens is you have multiple versions of the table, so when it just kind of, when you do your query, it says, okay, it's kind of like a snapshot. It's going to look at this snapshot of the table, and anything new that happens, it just ignores. And so you don't have to worry about, you can do writes, reads all at the same time. Cats and dogs living together, little chaos. It all just works together. Yes?
So what would be the effect of running those big select statements with no locks on them, on the previous slide?
Yeah, if you run the same ones here, come on. Yeah, it just, you're, it has
you
no.
showed the previous slide, right?
Yeah. So you run these kind of queries on a InnoDB table. It handles it with no problem because that update can happen while that select's happening. It doesn't have to wait. Nobody's ever waiting on someone else. It's not entirely true if you're trying to. There are cases where you'll get a deadlock if you have things that are, because you can lock a specific row, and if you're updating, if you have two things that are updating it's usually happening when you have multiple statement queries or transactions. And anyway, so you'll get, it has something called deadlock detection, and it says, basically these two are waiting for each other to finish in order to complete, and so neither one's ever going to complete. It'll throw out a deadlock and toss one of the queries. You'll have to, so you have to be a little more aware of that. It usually doesn't happen in most cases that I've had to deal with. You know, it just happens occasionally, and you just have to be able to deal with that. Usually it just means that your query failed and you try it again. Or, you know, maybe their page gives an error, they hit refresh and it's fine. So, okay, so yeah, so basically with multi-version concurrency, you're looking at the snapshot table of when you started. There's a little more to it. If you look into the isolation levels, there are different isolation levels, which is a really complex topic. We're not going to talk about it because most of you will never care about isolation levels. So the default isolation level, this is pretty true, and just we'll leave it at that. Okay, so batch writes. In MySQL, it has a great feature where you can do multiple rows of inserts all at the same time. You can update, you can do joins and on updates and deletes. You know, there's some cool features you can use to make it so instead of having to update, you know, one row at a time, you can just update a whole bunch or insert a whole bunch, you know, a whole batch of data. And if you have non-critical data, it might be worth storing it somewhere so that when you have a chance, you know, once every 10 seconds or once every minute, you can just batch write the whole thing in. You know, things like, you know, when did the user last log in? Well, you know what? For most cases, if something, you know, something catastrophic happened and you know, wherever you were temporarily storing that information, your memory was lost, you know what? It's not the end of the world if you don't know when the user last logged in. And so probably log in again a minute later, and you know, you'll have that information. So, you know, for that kind of information, if you don't care, you know, just kind of put it in memory somewhere and then batch write it up. NoSQL. So this is kind of big in you know, things that are trying to, different databases are trying to offer NoSQL interfaces. Postgres, I can find any information on Postgres having a NoSQL protocol. They do have NoSQL type data types where, you know, you can put in JSON and deal with basically virtual columns that way. MySQL can do that as well. In the latest, I know MariaDB, I think the latest MySQL has that as well. MySQL also has a memcached interface and the latest stuff. So you can actually interact with your InnoDB tables using memcached, which saves a lot of the overhead. You can't do very complex stuff. You're just inserting little bits of data. It's very useful. Handler socket is another one that you can compile into MySQL that will give you a NoSQL interface. All right. So Calvin Hobbes, best comic strip ever. Possible exception to the far side. This was one of the best ones. Calvin made a duplicator so he wouldn't have to do all his chores. He thought, well, I'll just make a bunch more of me and they'll do my chores. The problem is, they were all just as lazy as him, and no one wanted to do the chores. So replication, you know, people often, you know, you have a problem, you need to scale up your database. Oh, we'll replicate, that'll solve all the problems. No, it won't. It does have its uses. It can solve a lot of things, but it also introduces other problems. Basically, you know, you really have to think through what you're doing and make sure you're testing different situations. For example, what happens if the slave database gets behind by 60 seconds? You know, when your user goes in and edits their profile, and they click save, and it saves it to the master, and then it refreshes the page and loads it from the slave, and they get old information, and do they get frustrated? Because, like, I just changed that. Why isn't it what I just they're gonna get mad, and you're gonna get support calls, and things aren't good. So you have to think about those kinds of things. And it is possible, I mean, anything you write is going to have to be written on the slaves, so you're not really stopping those writes from happening everywhere. They're still going to happen, it's just, it may be a little more efficient. And I mentioned most ORMs have a debug console where you can see what actual queries are happening. It's good to make use of that. There's also, for MySQL, there's something called PT Query Digest from Percona. It's a great utility that you can attach it different ways. You can look at the binary log. You can actually just attach, like you can give it a TCP dump of your port 3306 traffic, and it'll analyze it and tell you what's going on, what queries are happening, which ones are taking a long time, that kind of thing. So, just keep everything running smoothly. You got to know what your database is doing. Use the tools that you've got to get a better idea of what's going on. If you don't know what queries are happening to your database, it's a good idea to find out. Just figure out what's happening, find out which ones are slow, use explain to find out, use these tools that are out there to find out, when you run this particular query, what is the server doing? What indexes is it using? What is it having problems with? And figure out, why that query is running slow, and if there's a way you can do it faster. So, all right. Thank you for coming.